Hello ma'am. My first question is what is isochoric process? Second question, solve one problem for constant volume process and show initial and final condition of steam with pressure volume diagram, temperature entropy diagram and enthalpy entropy diagram.
When any heating or cooling process is taking place in a closed vessel such as pressure cooker, then that process is known as the constant volume process, and it is also known as isochoric process. In this video, we are going to solve two problems for the constant volume process with the help of pressure volume diagram, temperature entropy diagram and enthalpy entropy diagram. Now I will read first problem. Steam at a pressure of 4 bar and dryness 0.7 is allowed to expand at a constant volume until the pressure rises to 5.5 bar. Find the final condition of steam and the heat absorbed by 1 kilogram of steam. So this was the given question. Let us first understand the given data. Initial condition is given, pressure P1 4 bar x1 0.7, that is the dryness fraction. Final condition P2 5.5 bar. Now we have to find out what is the dryness fraction at the point 2. So how to find out? So this process is the constant volume process and that is mentioned in the question. So we can say that V1 is equal to V2. Now we have to find out what is the value of Vg1 and Vg2 at a pressure of 4 bar and 5.5 bar. So for that we will refer here the steam table. Now in steam table we have to refer the pressure. So we have to take here the pressure table. That is the saturated water and steam. Inside the bracket there is the pressure that is mentioned. Now 4 bar and 5.5 bar we will measure here. So it is given, this is the 4 bar pressure and here the value is given Vf and Vg. So we have to take the value of Vg, because when V1 is equal to V2, then there is the formula x1 Vg1 is equal to x2 Vg2. So now we will have to take Vg1 and Vg2. So at 4 bar what is the value of Vg? That is 0.462. That is Vg1, and at 5.5 bar we have to take here the value, that is Vg 0.342. Now x1 is known, that is 0.7. Then what is the value of x2? So when we calculate we will get 0.945. Now we will draw this in the pressure volume diagram. Now if we observe, this is the process, that is the constant volume process. So V1 is equal to V2. And pressure at point 1 is 4 bar and the pressure at point 2 is 5.5 bar. Now how to show that? Now x1 is also given 0.7. So here if we observe, this is the pressure volume diagram. This is the wet region inside this saturated line and here is the superheated region. Now if we observe, at 4 bar there is the dryness fraction 0.7 and at 5.5 bar there is the dryness fraction 0.9. That means at the initial and final condition steam is wet. So we have to show the diagram inside this wet region. So pressure P1 4 bar. So suppose here is 4 bar and here is 5.5 bar. Then I will select here volume V1 is equal to V2. So this will be the point 1. So here is the pressure P1 and then V1 is equal to V2. So we have to show here the straight vertical line and then P2 is greater than P1. So here I will say here is P2. So this will be the point 2. Now we have to show arrow also. So this is the arrow from point 1 towards 2. And at this point here we can say V1 is equal to V2. And because x1 and x2 are there, so we have to show this vertical line inside the wet region. Now we will move for the next question, that is heat absorbed. So how to find out the heat absorbed, that is the change in internal energy U2 minus U1. So what is the formula to calculate U1? That is equal to H1 minus 100 P1 V1. Now why? Here is the number 100. So if we observe, pressure is given in bar. So what is the standard unit to calculate the internal energy, that is kilopascal. So here we have to convert this bar, that is equal to 100 kilopascal. That is 1 bar is equal to 100 kilopascal. So we have to take pressure in kilopascal. So we have to convert this bar in kilopascal, and that's why we have to take here the multiply here with 100. So here if this pressure is given in kilopascal, then there is no need to take this 100. Now how to calculate this H1? So H1, that is equal to, so for the wet steam we have formula H1 is equal to HF1 plus X1 HFG1. So for the pressure of 4 bar we have to use the steam table, that is the pressure table, and for this 4 bar we have to take the value of HF and HFG. So HF, that is 604.7, and HFG, that is 2132.9, and X1, that is 0.7, that is given, minus 100 P1. So pressure is given 4 multiplied by X1 0.7 and VG1. So V1 we have to take as a X1 VG1. So this is the formula to calculate the volume for the wet steam. So VG1 again we have to refer here with 4 bar, and it is given, that is 0.462. Now when we calculate this, 1968.3 kilojoule per kilogram. Now in the same way we will calculate U2, that is H2 minus 100 P2 V2. So if we observe this point 2, then this is also the wet steam. So same formula, that is for H2 HF2 plus X2 HFG2 minus 100 P2, that is pressure P2 5.5, and V2, that is X2 into VG2. So again we will take here the value, that is 955.8 plus 0.94 into 2095.9 minus 100 into 5.5 into 0.94 into 0.342. So when we solve this, we will get 2458.7 kilojoule per kilogram. Now we will take here the change in internal energy, that is U2 minus U1. So U2 minus U1, that is equal to 490.4 kilojoule per kilogram. So here if we observe enthalpy H2 is and enthalpy H1, or we can say that the internal energy U2 is greater than the internal energy U1. So heat absorbed, that is Q12 is equal to 490.4 kilojoule per kilogram. Heat absorbed, that means the change in internal energy. If we observe, U2 is greater than U1. So internal energy at this final condition, or the pressure 5.5 bar is greater than the internal energy at 4 bar. So we can say that there is the heat is getting absorbed in the process, and U2 minus U1 is 490.4 kilojoule per kilogram. So Q12 is equal to 490.4 kilojoule per kilogram. Now we will show this on the temperature entropy and enthalpy entropy diagram. So we know that as the heat is getting absorbed, then the entropy is getting increased. So we have to show this process, that is the increase in entropy as well as increase in temperature. So here is the point 1. Then heat is getting absorbed, that's why internal energy is getting increased, and at the same time here if we observe, here is S1 and S2. So entropy is also getting increased, and here is T1 and here is T2, that is temperature is also getting increased. We have to show arrow. So we have to show this point 1 and 2 in the wet region, because both are having dryness fraction. Now we will move for the next, that is the enthalpy entropy diagram. Now in enthalpy entropy diagram we have the dryness fraction 0.7 and 0.94. So here this inclined line indicates the dryness fraction. So we will say that this is for 0.7 and 0.94. Now if we observe, pressure is also given, that is 4 bar and 5.5 bar. So here are some inclined lines, that is for the pressure. We will say this is for 4 bar and this is for 5.5 bar. Now intersection of this 5.5 and that is we will first take 4 bar. So intersection of this 4.4 bar and at this 0.7, here will be the 0.1. And next intersection for this 5.5 bar and the 0.94, here will be the 0.2. So we have to take this, select these points, and we will show here this process, and this process is known as the process 1 to 2 in the enthalpy-entropy diagram. Now I will read the second question. A closed vessel of 0.2 meter cube contains steam at a pressure of 10 bar and temperature of 250 degrees Celsius. The vessel is cooled till the pressure of steam in the vessel falls to 3.5 bar. Find the final temperature, final dryness fraction, change in internal energy, heat transferred, and change in entropy. So this was the given question. Let us first understand the given data. Now initial condition of steam is given, the volume V1 0.2 meter cube, pressure P1 10 bar and temperature 250 degrees Celsius. So we will convert this temperature in Kelvin, that is 523 Kelvin. Now final condition of steam, that is pressure P2 3.5 bar is given. Now let us decide this temperature. What is the temperature for this pressure P1 10 bar? Now we will refer here the pressure table and we will find out what is the temperature at 10 bar. So if we observe here, that is saturated water and steam pressure table at 10 bar, the temperature is given 179.9 degrees Celsius. So this is the temperature for the saturated water and steam. But if we compare this temperature 179.9 and 250, 250 is greater than this temperature. So we will say that this temperature is the superheated temperature. So I will say this is the T superheated, that is equal to 250 degrees Celsius. Now if we have to plot this temperature on this temperature entropy diagram, then where we have to plot this T superheated and where we have to plot this temperature T1. So this is the superheated region and this is the saturated line. Now this temperature T1 is on, this lies on this saturated line, and T superheated is lies on this superheated region. And here this is on this saturated line, we have to plot this T1 because at 10 bar this is the temperature, that is the saturated temperature, and this is the T superheated and we have to plot here on this superheated region. Now how to find out the V superheated? So because of this temperature T is the T superheated, that is for the initial condition of steam is the superheated steam. So now we will find out what is the specific volume of the superheated steam. So in steam table, there is the table for specific volume of superheated steam, that is given. So at a pressure 10 bar and temperature 250 degrees Celsius, we will find out what is the specific volume. So if we observe, here in the first line there is the pressure is given, that is 10 bar, and here the temperature is given on this horizontal line, this is the 250 degrees Celsius. So if we observe, here is the specific volume, that is 0.2244 meter cube per kilogram. So we have to take this V superheated. Now we will find out what is the mass of steam. So how to find out? We have to take the ratio. So this is the total volume is given and this is the volume, that is for superheated steam. So if we take the ratio for V1 by V superheated, then we will get the mass of steam. So M is equal to 0.2 divided by 0.2244, which is equal to 0.89 kilogram. So this is the mass. Now we will move for the first question, that is we have to find out what is the final temperature of steam. So final temperature of steam, if we observe, final condition of steam is at a pressure of 3.5 bar. So again we have to refer here the pressure table, and we will find out what is the temperature at 3.5 bar. So in the pressure table, in the first column pressure is given in bar and temperature is given 138.9 degrees Celsius. So we will say that T2 is equal to 138.9 degrees Celsius. Now we will find out the final dryness fraction of steam. It is given that the steam is cooled inside a closed vessel. So this is the case of the constant volume process, that is the isochoric process. So we will say that V1 is equal to V2. So V1, that is, it is the initial condition of steam is the superheated steam. So we will say that V superheated is equal to V2 and V2 is equal to X2 Vg2. So what is the value of V superheated? That we have find from the superheated table, steam table, that is 0.2244, which is equal to X2 and Vg2. So how to find out Vg2? That is at the pressure of 3.5 bar, it is given that the value of Vg2. So in the steam table, in pressure table 3.5 bar, here is the value of Vg2, that is 0.524. So X2 is equal to 0.43. So here is the dryness fraction. So we can say that the initial condition of steam, that is, it is the superheated steam because temperature is T superheated, and final condition of steam because the dryness fraction, it is the wet steam. Now we will draw here the diagram. So how to show here in the pressure volume diagram. So initial pressure is 10 bar and temperature is T superheated. So I will show that at pressure of 10 bar and in the superheated region I will show this point 1. So this is the pressure P1, that is 10 bar. Now cooling process is taking place and final pressure 3.5 bar. So we have to show here, that is the below, this is the pressure P2. Now volume remains constant. So we have to show here point 2. So if we observe here, V1 is equal to V2. So initial condition is superheated region and final condition, that is in the wet region. Now we will find out the change in internal energy U2 minus U1. Now if we observe point 1 is in the superheated region. So how to calculate the internal energy at point 1, that is U1, that is H superheated minus 100 P1 V superheated. So enthalpy and the specific volume we have to find out from the superheated steam table. And 100 is used here because the pressure is given in bar but standard unit is kilopascal. So we have to convert this bar into kilopascal by multiplying with 100. Now here initial condition, pressure is 10 bar and temperature is 250 degrees Celsius. So on the vertical line in the first column pressure is given and horizontal line temperature is given. So at the 10 bar and 250 degrees Celsius, here the enthalpy is given 2943. So we have to take here 2943 minus 100 into 10 into V superheated. So superheated steam, that is V superheated, is we have calculated earlier 0.2244. So U1 is equal to 2718.6 kilojoule per kilogram. Now we will move for the next, that is calculation of U2, that is the internal energy at point 2. So point 2 is in the wet region. So we have to take the formula H2 minus 100 P2 V2. So for the wet region there is the dryness fraction X2. So how to calculate H2? That is HF2 plus X2 HFG2. So now at 3.5 bar pressure, so in the pressure table we have to take here 3.5 bar pressure and we have to find out the value of HF and HFG. So value of HF and HFG is here. So at 3.5 bar here HF and HFG is given. Now we will put this value as well as V2 is equal to X2 Vg2. So at the same pressure, that is 3.5 bar, here is the Vg. So we have to take this value. So 584.3 plus 0.43 into 2147.3 minus 100 into 3.5 into 0.43 into 0.524. So when we calculate this, we will get 1428.6 kilojoule per kilogram. Now change in internal energy, that means U2 minus U1. But if we observe U2 is less than U1, that means there is the decrease in internal energy. So U2 minus U1, when we calculate this, then we will get the minus value, that is minus 1290. Now what is the total change in internal energy? Because we have calculated mass. So this is the internal energy per kilogram. That is U2 minus U1 if we take, then we will get in kilojoule per kilogram, but mass is given, that is 0.89 kilogram. So we have to multiply here with 0.89. So total change in internal energy, that is minus 1290 into 0.89, which is equal to minus 1148 kilojoule per kilogram. So this is the answer for change in internal energy. Now we will show this on this temperature entropy diagram. Now it is important to show because here negative sign is there. That means internal energy is getting decreased from point 1 to point 2. So whenever the internal energy getting increased, that is heat is getting removed and entropy is also getting decreased. So we have to show here from point 1 to the point 2 decrease in entropy as well as decrease in temperature. Now we will select first the point 1. Now if we observe, here is the T superheated. So this T superheated, that is in the here in the superheated region. So I will show this T superheated. So here T superheated is there. Then there at this 10 bar pressure there is temperature, that is T1 is there, that is 179. So T1 lies on this saturated line. So if we observe, I will show this, that is T1. And then T2, that is also less than this T1, that is 138. So I will show somewhere here, that is T2. Now we have to show decrease in entropy as well as decrease in, so decrease in temperature is already there if we plot all the temperatures. So this point 2 is in the wet region with dryness fraction 0.43. So we will select here the point. Now here is T superheated, then T1 and T2. Now decrease in entropy, that means from point to 1 we have to show here. So this will be the here is the superheated point. So but I will say this point 1 and here is the point 2. I will show arrow also. So there is the decrease in entropy because the negative sign is there. So in this way here this temperature entropy diagram is getting completed. Now we will move for the next question. So change in internal energy, that is nothing but the heat transfer, and it is having same answer, that is the heat transfer, that is Q12 is equal to minus 1148 kilojoule per kilogram. So here only kilojoule is there because we have multiplied with mass m. So only kilojoule is there. Now we will move for the next question, change in entropy. So change in entropy, we have to find out the entropy at point 1 and entropy at point 2. So entropy at point 1 is in the superheated region. So if we observe in the table, superheated steam table is given for the entropy, that is the specific entropy of superheated steam. So at 10 bar pressure and 250 degrees Celsius temperature, we can easily find out what is the entropy. So here this is the 10 bar pressure and on the horizontal line 250 degrees Celsius temperature is given and S superheated, that is the entropy 6.926 kilojoule per kilogram Kelvin. Now we will find out the entropy at point 2. So point 2 is in the wet region. So S2 is equal to SF2 plus X2 SFG2. So at this point 2 pressure is 3.5 bar. So again we will refer here the pressure table. So in the pressure table at 3.5 bar, here is S2. So if we observe SF, SFG values are given. So SF, that is 1.727 plus X2, so dryness fraction 0.43 multiplied by SFG. So SFG is also given, that is 5.212. So here it is given. So S2 is equal to 3.97 kilojoule per kilogram Kelvin. So we will find out it's a change, that is we will take the difference S2 minus S1, that is minus 2.956. So negative sign is there, that means there is the decrease in entropy. So if we observe during this point 1 and point 2, so here is S1 and here is S2, so here is also decrease in entropy and total change in entropy. So we have to multiply here with mass m, that is 0.89. so if we multiply this, then we will get minus 2.63 kilojoule per Kelvin. So this kilogram is getting cancelled because we have multiplied with mass m. Now we will show this on this enthalpy entropy diagram. So how to show that? Now if we observe for the point 1, there is the pressure and temperature is given. So if we observe, here are some pressure lines in this way. So suppose this is the pressure line for 10 bar and here horizontal lines are the temperature lines. So suppose here is the temperature line with 250 degrees Celsius, then here this point of intersection is nothing but the point 1. So this point 1 is in the superheated region, so we can easily see this in the molar diagram, that is nothing but enthalpy entropy diagram. Now how to select the point 2? So point 2 is nothing but it is for pressure P2 3.5 bar and dryness fraction x2. So we have to take the point of intersection. So here is the 10 bar. Then if we observe before this 10 bar, here are some lines and we will select here the line with 3.5 bar. So I will show this is the 3.5 bar line. Now we have to take the dryness fraction, that is 0.43. So if we observe at the bottom, here these inclined lines indicate us the dryness fraction. So here suppose this is the line 0.43. Then we will take the intersection for this pressure 3.5 bar and dryness fraction 0.43. That will be our point 2. So this point 1 and point 2 is getting selected. Now I will remove all the other work. Now we have to join these 2 points. So I will join these 2 points. We will show arrow also. So this is the process 1 to 2. So here also entropy is getting decreased, and in this way all the diagrams are getting complete.